Okay, another couple of sequences, converge or diverge. If converge, find what it converges to. So in general, you want to take a limit. Okay, so it's as I'm writing this down, I'm recognizing all the exponent things. So I'm wanting to get it to a point where I can use that k limit theorem, right? So k to the n. So what number to the n do I have here? So this can be rewritten as 4 squared times 4 to the negative n times 3 to the 2n, right? So 4 squared, that's just 16. I'm just going to pull it straight outside the limit. So then I have 4 to the negative n, so I'm going to have this 3 to the 2n over 4 to the n. So what number is it to the nth power? That's what I want to check out. So here I would have 9 over 4 to the nth power. Since this number here is larger than 1, then that means that this equals infinity, so it diverges. Okay, I just noticed something I was doing here. Okay, so let's change this one. Okay, so here we go. So here's another one. So limit as n goes to infinity, 2 to the 1 minus 2n, 3 to the n. Sorry, that was kind of messy. All right, so if I check, just kind of play with the exponents here, 2 to the 1 times 2 to the negative 2n times 3 to the n. This 2 can come outside. Again, I want to find out what number it is to the nth power. So here's 3 to the n. This can come downstairs as 4 to the n. So I see that the number to the nth power is 3/4. That equals 0, so it converges. Okay, and so one other thing that is a common thing, oops, that I've given it many homework problems about, something like this. So if you take the limit as n goes to infinity of this, you know that this is the nth root, so it looks like this. Now plug in infinity up here, and I get 1 over infinity, which is 0. 3 to the 0 is 1. So that converges. So this is not to the nth power, it's the 1 over n power. Okay, so then the last thing, I wanted to, the last case, I guess, of the in sequences is the ASR. Okay, so ASR is when you have -1 to the n times, say, arctangent of n. So this rule says, you've got it in your notes, this rule says you take the limit of the positive part only. And if that limit of that positive part does not equal 0, the whole thing diverges. So I take the limit of the positive part, it equals pi over 2. Since it doesn't equal 0, I can say that this sequence diverges. So if I had -1 to the n, cosine of 2 over n, if I take the limit as n goes to infinity of cosine of 2 over n, if I put in infinity, I get cosine of 0, which is 1, doesn't equal 0, so it diverges, right? So it's only when the limit of the positive part, so let me give you a nice one that does work, 2n over 3n squared plus 4. Okay, taking the limit of the positive part, 2n, 3n squared plus 4. I wouldn't use L'Hopital's. I would just go right to highest powers. So 2n over 3n squared. N's cancel. So I get 2 over 3n. That gives me 0. That means it converges. Okay, so that's a little bit of a review of sequences.